Chapter 15, we're going to discuss chemical equilibrium. And specifically, section 15.1 is just going to be a quick introduction to equilibrium. Let's look at the Haber process. In the forward direction, we're starting with hydrogen gas and nitrogen gas and mixing them together to get ammonia. Since it's in the forward direction, we're going to use a forward arrow to describe that. However, if we reverse this, as in we just flip everything around, and we now are starting with NH3 and having it become hydrogen gas and nitrogen gas, that's what we would consider the reverse direction. When the rate at which the H2 and N2 combine to form the ammonia equals the rate at which ammonia reforms to make H2 and N2 is when it's in a state of equilibrium. So in summary, if the rate of the forward reaction equals the rate of the reverse reaction in equilibrium. And we will use a double arrow, or it'll look like that, to denote that the reaction is occurring in both directions at the same time. Here's a graph that shows the rates of the forward and the reverse reaction. So we're starting with nothing but the reactants and no products. And as that reaction is happening, eventually they're going to become or go into equilibrium with each other. And that's usually when this tapers off and it's very smooth. So that just means that the rate of the reverse reaction is equal to the rate of the forward reaction. Substances on either side of the arrow are both reactants or products, so some conventions apply. So substances written on the left side of the arrow is what we consider the reactants, even if it is a double-sided arrow. Substances written on the right-hand side are what we consider the products. So the forward reaction refers to substances on the left producing the substances on the right. When this occurs, the reaction proceeds to the right. So it's always going to be reactants on the left and so that forward reaction is the same thing as proceeding to the right, meaning that the products are going to be favored and then products are going to be formed. The reverse reaction refers to substances on the right producing substances on the left. When this occurs, the reaction will proceed to the left.